This is 10.4, solving radical equations. To solve a radical equation, we first want to isolate the radical. So as you can see here in example 1, the square root of a plus 5, and then adding 7 is outside of the radical equals 12. So our goal is to get the radical by itself first. So we're going to undo the addition of 7 by subtracting 7 from both sides first. You're going to get the square root of a plus 5 equals 5. Now to undo a square root, we can square both sides. So I'm going to square the left and square the right. So the square root of a plus 5, and we're squaring that, the radical just disappears and you're left with a plus 5. And 5 squared is 5 times 5, which is 25. Now this is an easy one-step equation. Subtract 5 from both sides, and a equals 20. So as we always solve equations, we should check our answers to make sure it makes sense in the original problem. So make sure when you're doing the problems for homework that you're solving, showing the work, and showing a full check. So the first part of the check is to write the original problem down. Square root of a plus 5 plus 7 equals 12. We're going to substitute our a for the answer that we found, which was 20. Then we're going to follow order of operations. We're not going to solve it like we did on the left. So 20 plus 25, or 20 plus 5 is 25. We're going to put that under the square root, and we're going to prove that this equals 12. So the square root of 25 is 5, add 7, and 7 plus 5 is 12. So 12 equals 12, and it checks out. So notice the right side of your check stays a 12 the whole way down, and so you prove that the left side actually equals 12. I'll do one more example like this one. So this is example 2. We have 4 plus the square root of h plus 1 equals 14. So again, our goal is to get the variable by itself first. So we are going to subtract 4. You're going to have the square root of h plus 1 equals 10. Now to undo that radical sign, we need to square both sides. So the square undoes the radical. Those are inverse operations, so it's just h plus 1 on the left, and 10 squared is 10 times 10, or 100. And then the one step, subtract 1 from both sides, and h equals 99. So again, we need to check our answer in the original problem. So I'm going to write the original. I'm going to see if this equals 14 when h is 99. So 4 plus the square root of 99 plus 1 equals 14. 4 plus 99 plus 1 is 100, so I have the square root of 100 equals 14. The square root of 100 turns into a 10. And 4 plus 10 is 14, which equals 14. So it checks out. So make sure you're showing all steps of your check. The next problem I'll show you is when you have variables on both sides. So I'll show you 2 examples of these types. So this is going to be example 3. You have k plus 1, the square root of that on one side, and a k plus 1 on the right side. And we're going to solve and check this. So again, we want to figure out how to get the radical away. So we're going to square both sides. So on the left, the square and the square root undo each other, and you get k plus 1. And on the right, this is a little tricky. This does not just bring down the k minus 1. You have to do the box method off to the side. Or you could FOIL. but most of you remember the box method. You have a k minus 1 and a k minus 1. So this is k squared, this is negative k, and a positive 1. So this now is k squared. A negative k and a negative k on the diagonal makes negative 2k, and then plus 1. So our goal here is to get everything on one side of the equal sign. So I'm going to subtract the k over. You get 1 equals k squared minus 3k plus 1. And then you're going to subtract the 1 over. So everything's on one side and it's set equal to 0. So the 1 and the minus 1 divide or subtract out. So now we have something that looks like this. We're going to factor by a greatest common factor. Each term has a k that will divide out, and you get k times k minus 3. And if two things multiplied equals 0, we can know that k is equal to a 0 for the first part, or in this part right here, k is equal to a 3. So we should check these answers because sometimes one of them works and one does not. So I'm going to go over here and check. So the first one I'm going to check is k equals 0. So I go to my original problem, I substitute the k as 0 on both sides and see if this is true. So 0 plus 1 is a 1, the square root of 1 is 1, and 0 minus 1 on the right is negative 1. So these do not equal. So k equals 0 is not a solution. Likewise, we're going to do the same thing with k is 3. So we're going to check k equals 3. Go back to your original, substitute that in. 3 plus 1, the square root of that, and 3 minus 1 on the other side. This is the square root of 4, which is a 2, and 3 minus 2 is 2. So k equals 3 is our only answer for this problem. All right, and I'll do one more example for you, like this with variables on both sides. This is example 4. On the left, we have x minus 3. On the right, we have the square root of x minus 1. So our first step is to undo the radical by squaring both sides. This time, the left side, we need to do the box method. So I'm going to go off to the side here and do the box method on x minus 3. So this is going to be x squared minus 3x minus another 3x and a positive 9. So on the left side, you get x squared minus 6x plus 9. And the square root, when you square a square root, that undoes each other, so you get x minus 1 on that side. Now we're going to bring everything to the left. So I'm going to subtract the x first. You get x squared minus 7x plus 9 equals negative 1. We're going to add 1 to bring everything over. So you have x squared minus 7x plus 10 equals 0. Now we need to factor this trinomial like we did in the previous chapter. So you need to think about numbers that multiply to 10 that add up to a negative 7, and they are negative 5 and negative 2. So this is x minus 5 and x minus 2 equals 0. Then if you think two numbers multiply to 0, so in the first part, x can be 5 because that turns the first part to 0, and in the second part, x could be 2. That makes this part 0. So now we're going to check to see if both of these are equivalent in the answers to our problem, or just one of them or none of them. So let's check x equals 5 first. So go back to the original. It was 5 minus 3 and the square root of 5 minus 1. So 5 minus 3 is 2. 5 minus 1 is 4, and the square root of 4 is 2. So x equals 5 works out. The second solution we should check is x equals 2. So again, I'm going to substitute the 2 into the original problem. The left is 2 minus 3, and then the square root of 2 minus 1. So 2 minus 3 is negative 1. 2 minus 1 is 1. The square root of a 1 is 1, which does not equal negative 1. So x equals 2 is not a solution. So x equals 5 is the only answer here. So for homework, you're going to have 2 example problems to do. One that will be similar to the first 2 I showed, and then one that's similar to variables on both sides. Please rewatch the video if you need extra help or to listen to it again. Watch the notes. You will also have a wrap-up question that you will need to do as well. So you're going to have 3 problems to do on a piece of notebook paper, and take a picture, show your work, solve them, check them, and upload your paper to Google Classroom.